Hello, my name is Adam, and in this video we're going to go through some practice problems applying the periodic trends. So right now you're going to want to pause the video if you don't already have out a copy of your periodic table. I'm going to draw an outline of the periodic table so that we can draw arrows as a reference for our periodic trends and also identify relative positions of atoms. So we're going to start off with electronegativity. The trend for electronegativity is increases as you go up the periodic table and also increases as you go from left to right. So we're going to get a list of elements and we're going to identify their relative electronegativities to each other by ranking them in order from highest to lowest. So we have potassium, boron, nitrogen, fluorine, and beryllium. So we're going to identify where these are on our periodic table and then compare them relative to each other so we can rank them. So we know fluorine is the most electronegative atom on the periodic table, and it's right here. So this is going to be our number one. This is the most electronegative. Next, we have nitrogen, boron, over here, beryllium, and down here, potassium. So as we go from right to left, it's decreasing. So we have fluorines first. Next largest electronegativity is nitrogen, then boron. Then we come over here to beryllium, further to the left. And then we go down two groups, and that shows us that potassium is the least electronegative element on our list. So it goes here. So this is how we'll generally solve problems using periodic trends, is to identify their position on the periodic table and then relate them to each other in reference to the trend. The next trend we're going to go over is ionization energy. And for ionization energy, the trend is the same as electronegativity. It increases going up the periodic table and increases going from left to right. So we look at a new set of elements and identify which one has the greatest ionization energy and all the way down to which one has the lowest ionization energy. For this, we will use bismuth, oxygen, nitrogen, phosphorus, and antimony. So identify where these are on our periodic table and then figure out how we're going to rank them. So bismuth is down here, antimony, phosphorus, nitrogen, oxygen. So as you go up and to the right, your ionization energy increases. So oxygen has the highest ionization energy. Next will be nitrogen as it's further to the left. And now we'll look going down to rank them. So phosphorus is below nitrogen, so it's the next. Antimony is further down, and then bismuth is below that. So that's how our ranking will go. Antimony and bismuth. So once again, all we have to do is establish what the trend is and then identify the position of the elements on the periodic table in order to rank them. Next, we'll look at atomic radius. Atomic radius has a different trend than these two. Atomic radius increases as you're going down the periodic table and also increases as you're going from right to left. For this, we're going to look at oxygen, carbon, strontium, and barium. Once again, we'll identify where they are on the periodic table and then look at them to determine their relative atomic radii. So first we have oxygen, carbon here, strontium here, barium here, and we know as you go down, your atomic radius increases. So barium has the largest atomic radius. Right above it is strontium. Now we're going to go up and to the right, still decreasing, and we get to carbon. And further to the right is oxygen, so it has the smallest atomic radius. Okay, this is one way that you can apply the atomic radius periodic trend concept. Another way to do it is to look at an isoelectronic series. I'll write one on the board now. So you have sulfur 2 minus, Cl minus, argon, and then potassium plus, and Ca2 plus. Okay, so we know that all of these right here have 18 electrons. So the only thing that's different between them that's going to affect their atomic radius is their protons, because they all have different numbers of protons. So we know as you have more protons, your atomic charge increases, and as your atomic charge increases, you more tightly hold in your electrons, and therefore have a smaller atomic radius. So calcium 2 plus has the most protons and has 18 electrons like all these other elements, so it's going to be the smallest of this isoelectronic series, and it'll increase going this way as number of protons decreases. So there you have it. That's how you determine the relative sizes of an isoelectronic series of elements. And that's all I have for you today, covering periodic trends. Thank you for watching.